From mathematical relations point of view, we're going to see how the concept of relational models apply. Relation is any subset of Cartesian product. What is Cartesian product? When we consider two sets, D1 and D2, D1, for example, consists of two members, 2 and 4, and D2 consists of three members, 1, 3, and 5. Cartesian product of D1 and D2, read as D1 cross D2, is set of all ordered pairs where first element is member of D1 and second element is member of D2. For example, D1 cross D2 equals 2, 1, 2, 3, 2, 5, 4, 1, 4, 3, and 4, 5. Relation is any subset of Cartesian product. For example, relation R equals 2, 1, and 4, 1. What if there is more than two sets, for example, D1, D2, and D3? So the Cartesian product of these three sets equals 1, 2, 5, 1, 2, 6, 1, 4, 5, 1, 4, 6, 3, 2, 5, 3, 2, 6, 3, 4, 5, 3, 4, 6. So we try to combine every single member from each set to become another set. So any subset of this order triples is a relations. So now, what about the properties of relations? Relation name is distinct from all other relation name in relational schema. Each cell of relation contains exactly one atomic value. Each attribute has a distinct name. Values of an attribute are all from the same domain. Each tuple is distinct. There are no duplicate tuples. Order of attributes has no significance. Order of tuples has no significance, theoretically. So, for example, from this table, we do have distinct name of the relations. And then every single value is atomic. We do have distinct name of attributes, and the order doesn't matter. Every value from the same attributes come from the same domain. All the records is distinct. Order also doesn't matter. Now we talk about the relational case. We know there is several types of K. First one is super K, an attribute or sets of attributes that uniquely identifies a tuple within a relation. A super K is a group of single or multiple keys which identifies rows in a table. A super K may have additional attributes that are not needed for unique identifications. And now, how about candidate K? Candidate K is a super K with no repeated attributes, and the primary key should be selected from the candidate K. Every table must have at least a single candidate key. So, for this example, employee SSN and employee number are super keys. Primary key is a candidate key being selected to identify tuples uniquely within relation. Composite key is a key which is the combination of more than one field or column of a given table. An alternate key is the candidate key that are not selected to be primary key. And foreign key is attributes or set of attributes within one relation that match candidate key of some or possibly same relations. So, student ID is the primary key. Roll number and email is an alternate key. Student ID, roll number, and email. Those three are candidate keys. For integrity constraints, there are two important integrity rules, which are constraints or restrictions that apply to all instances of the database. The two principal rules for the relation model are known as entity integrity and referential integrity. Null represents value for an attribute that is currently unknown or not applicable for tuple. Deals with incomplete or exceptional data, represent the absence of a value and is not the same as zero or space, which are values. Entity integrity in a base relations, no attribute of a primary key can be null. Referential integrity, foreign key value must match a candidate key value in its home relation, or foreign key value must be null. For example, it should not be possible to create a staff record with branch number B025 foreign key, for example, unless there is already a record for branch number B025 in the branch relation, like this. We have two relations, staff and branch. This called entity integrity, staff ID, which are all unique. This called referential integrity, from branch ID to branch ID in the branch relations. How about the fuse? Base relations is a name relation corresponding to an entity in conceptual schema whose tuples are physically stored in the database. Fuse is dynamic result of one or more relational operations operating on base relation to produce another relation. Fuses are a virtual relation that is produced upon request at the time of request. The content is a query on base relations. It is dynamic, which means changes made to base relation are immediately reflected. Fuse can hide parts of database from certain users. It can also simplify complex operations on base relations. With different users, different ways to see the data at the same time.